Hey guys, let's go over some basics for angled projectiles here. And then we'll do a couple example problems in some separate videos. So an angled projectile is anything that is thrown at an angle, not horizontal. So a ball thrown at an angle, here's an important thing to realize, has a vertical and a horizontal component of velocity. So here is the overall velocity of the ball that you actually threw it at, but we can say that it has a vertical part of it and a horizontal part of it, or components there. So we already know how to resolve vector into horizontal and vertical components. We've practiced that already in class, and so we can do it right here as well. So here's how we do it. Let's say you have some initial velocity represented by the green arrow. This is what you actually threw it at. And you throw it at some angle, we'll call that angle theta. So if you want to find the horizontal component right here, so the Vx initial, we could call it, you would do that with the cosine function because it is the adjacent side right there. So the adjacent side will equal the hypotenuse times the cosine of the angle, or the Vx initial will equal the V initial times the cosine of the angle. Now, lots of times I will, and you'll see other people drop this initial right here for the Vx. It's not really necessary because the horizontal velocity will never change at all because there's no forces horizontally, if we ignore air resistance, to change it. Vertically, to find this blue arrow here, this vertical component, we would call that Vy initial. So since that is the opposite side of the angle, we will use the sine function to solve for that. So the Vy initial is equal to the V initial times the sine of the angle. Make sure your calculator is in degree mode when you do these problems here. So now let's go on to a specific example here. So let's say you throw the ball at 100 meters per second at an angle of 53 degrees. So this overall velocity is 100 meters per second, and we throw it at 53 degrees. We'll use what we just talked about in order to find the components here. So if to find this one, it would be 100 times the cosine of 53 would give you 60 meters per second would be our horizontal component. And then if we wanted to find the vertical component, by the way, this vertical component, they've got it drawn right here, but it'd be the same if they drew it right here. So 100 times the sine of 53 would give you 80. So this ball is going initially 60 meters per second to the side and 80 meters per second vertically. Now, again, it's important to realize this. Let's say we throw something up at 20 meters per second. That's the vertical component. And sideways at 15 meters per second. That sideways motion, that Vx, will never change. It will stay 15 meters per second here, stay 15 meters per second at the top, and as we go on down the next way, 15 meters per second and 15 meters per second. That will never change the whole time. But the vertical motion will change. So if we initially go up at 20 meters per second, then 1 second later, we'll only be going 10 meters per second vertically. And 1 second after that, we won't have any vertical velocity. Although it's really important to realize you will still have a horizontal velocity. Then on the way back down, now we mirror what we did over here. They're just negative velocities. So now our vertical velocity is negative 10 meters per second. And 1 second after that, our vertical velocity would be negative 20 meters per second. Notice if you throw it up with a vertical component of 20 meters per second, it will take you 2 seconds to get to the peak and 2 seconds back down for a total of 4 seconds. By the way, what if we would want the overall or the resultant velocity? So how would we get that it was thrown at 25 meters per second? We would use the Pythagorean theorem. So one side is 15, the other side is 20. So 15 squared plus 20 squared, take the square root and you'd get 25. You would do the same thing here. 15 squared plus 10 squared would give you, square root of that would give you 18. And if you did the Pythagorean theorem over here, you would also get 18 and also 25. These things would have different directions though. So last thing here, before we move on to the example problems, is remember that the total time up is equal to 2 times the time it takes to get up. So whatever your initial vertical velocity is, you divide that by 10. That will give you the time up, and then double that. That will give you the total time.